Hello, everybody, and welcome to Getting APIs to Work. Today, I say hello to Phil Sturgeon from APIs You Won't Hate. Hi, Phil. How are you doing?
Hey Eric, what's up?
Not much, not much. Thanks for joining. You're on your boat, which is the first
Yeah,
time ever that I'm saying that to a guest. Very cool.
absolutely. You can hear young ducks in the background, so sorry about
Okay, that's an okay noise to have, I would say. So the last time we talked about green IT. That was a couple months ago, and you were saying that you were thinking about writing some articles that talked about how green IT, as a general concept, or green software, sorry, is something that also translates a little bit into the API space. So let's just rehash that very briefly in terms of how the ideas of green software specifically can apply to the API space.
that. Yeah, okay. So green software is a really wide field, and it's getting bigger and more interesting all the time. But when we talked about it, some of the basic concepts are kind of tracking the emissions, the CO2 emissions, and the resource usage of your software, and then trying to reduce that. Right, climate crisis is bad. Not sure if you heard about it. So we're all trying to make sure we can do what we can, and there is quite a lot of scope for improvement because what are the numbers I usually use? Like 4% of global emissions are coming from the internet and the various connected devices, and 83% of that is API traffic, web traffic, like JSON and YAML binging about all over the place. So if we can make our APIs more efficient, need less binging about all over the place of that data, we can genuinely put a decent dent in global emissions, in a way that like we can't go out and say don't fly, no one fly ever again. But it's a similar size amount of CO2 coming from the internet, which we can do something about.
Yeah, and I think the interesting thing is, right, on the one hand, you could, of course, tell people, okay, don't even, I don't know, why do you have to connect your scale to the internet or something like this? That's one thing.
Yeah,
But the other thing then also would be something like, okay, but if you feel the need to interconnect things, at least do that in a responsible way. And I think this is what we were talking about a little bit. And the idea there was to look a little bit at caching. You recently wrote two articles, I think, on caching, one on caching in general and one on like a specific framework. And I highly recommend both articles. The first one is an excellent introduction to the general framework of what caching means, in particular for HTTP APIs. And the other one is a little bit more specific about one framework. But if you had to very briefly summarize why that is a useful thing to know about and to maybe even part of your practices, maybe your guidelines, right? Where if you do an API review, put that into the review criteria where you tell people, hey, have you thought about restructuring it, right? These kind of things.
yeah.
So how does caching play into that?
I think caching, HTTP caching specifically, right, where you're kind of adding things like cache control headers and ETags, and then letting the entire HTTP spec do its thing the whole way through things like various CDNs and caching proxies, and all the way down to the browser or any sort of HTTP client that knows how to handle those caching things. I think we generally completely ignore it. Like so many of us, I've done this before. We completely ignore the concept of caching until the server bills get a little bit too high, and then someone says anything we can do about these server bills, and you go, well, I finished optimizing the database queries, so maybe we can put a few cache headers on there, and it's not very much, and it's not very helpful to think about it that late in the game, because you might find that a lot of your data isn't really that cacheable, depending on the way that you've kind of designed your API and the way you've broken down these resources, especially the way that, we've spent years and years designing APIs for kind of HTTP 1.1, where you basically mush loads of vaguely relevant information into one giant query, so you don't have to make two requests. If you do that, then you quite often kind of poison the cacheability of your data by having something that is very, very specific to that user mixed in with something that could be completely generic and available for everybody. So, um, kind of focusing on HTTP caching means you can reduce how many requests your clients need to make, and not only how many requests they need to make, but when they do make a request, they're going to get it more often from an edge server. If you're using these CDNs like Fastly, Cloudflare, they push those cached copies to CDNs all around the world, or you can select where. And that means that if a request does need to be made by the client, and it is something that's not in that kind of edge CDN, then it is going to come back to the origin server, and that reduces how much traffic that you're kind of worrying about responding to, and those application servers do less work. So some people think about it as an optimization, but it's more like, this is just how you should do it. This is how websites work. This is how the internet's meant to work, and we just don't do it. And if you do decide that you want to do it, then it's a case of deciding, like, making it part of the design process, thinking about it before you build the API, as you build the API, so that you have a better API. Because the only thing that comes as a result of making an API more cacheable is you have an infinitely better API with much better separation of concerns for all of the resources in there, and it's just more usable.
I mean, one of the things that I really find fascinating in that case is that we have just a lot of useful things to reuse there. The web works very well, and the caching mechanism for the web has been around for has been fine-tuned in many ways. Right? So I think that's something that the API space can very easily reuse, and like you said, it really doesn't do that enough. And in particular, when you think about APIs that get used a little bit more, it really can make an impact. I think that that's definitely the case. And as you said, it's a little bit like security, I would say. If you treat that as something you do at the very end, it typically doesn't come out very well. And I think that caching is the same kind of thing. You really have to start thinking about it very early on, so that you can do kind of the right segmentation of your resources into those that are cacheable and those that are maybe not as easily cacheable. And another point that you made that I found was really interesting was this, and it never dawned on me, I think, that way, that with the improvement of HTTP through 1.1 and 2 and now 3, kind of this almost like instinct that we had to reduce requests, right? That doesn't really matter that much anymore. You have header compression, and I mean, you have so many things now that actually mean that the number of requests is not such a big deal. If you want to do more requests, that's fine. It doesn't come at a great penalty. And I think that's something, just when you said it, that's something that I still haven't kind of internalized enough, I think. It's another thing that we might still think about a little bit too much, right? It's like, even in the old days, right? It's like there's one individual TCP connection for each request. Like, okay, in that case, things are a little different.
Yeah, it's the kind of the HTTP 1.1 mindset, and things like JSON API and GraphQL just really kind of enshrine this method of thinking of just like, the scariest thing is making multiple requests. And so you better mush everything possible into that one request. And then if any of that stuff is being computed on the fly or whatever, then that's very slow each time. And if you have lots of different resources, right? Like the example of invoices, you've got get invoices /ID, and then it loads up the invoice itself and the items. Maybe that's okay, but then the customer and the like payments with the payment status. And if any one of those things has changed, you can't cache any of that. And so you can kind of think about the cacheability of different things, but you could also move some of those kind of nested resources into their own link. So you could literally have links at the bottom with customer and payments, so people can go and fetch the data if they want it, and all of those can have their own different cacheable rules, cacheability. So the more you split things up, the more performant each one of them will be, but you might not even need to make that request because it's cached in the client and or the edge, and eventually go to the origin only if you need to, instead of just always forcing all of that stuff every time down the line.
Since you said that, I'm wondering, I would think, I don't know, of course, but I would think that most API reviews, if you have your review process in companies, don't even look at cacheability. You know, it's kind of like this implementation thing that, yes, maybe we slap on some cache headers if it is possible. Yeah. But it's not even part of the discussion that you talk about, is that thing cacheable? If so, for how long? And if it's very short, then can we change things around? Have you seen in your practice, I'm wondering, have you seen that even part of the conversation and the necessary information being there? Or is that really something where it's so deep in the implementation that people don't even make that part of the conversation at that point?
Yeah, I mean, when I'm helping out with kind of API consulting for various companies, like it just never comes up. I'm always the one to bring it up. it's wild how few people do this, because when you part of it is people don't understand caching very well, which is why I'm creating a lot of resources to help people understand caching a bit better. But part of the problem is, yeah, part of the problem is people don't understand it, and therefore people don't have much experience with it, and therefore it's confusing and scary, and therefore they don't. But I think when you think of caching as really a simple, like, I'm going to stick a 1 hour cache on this thing, and no matter what you do, no one can ever get fresh information. That's how people think of it, and neither of those things is true. Caching is not just sticking a really long expiry time on things, and people can get fresh data if they want to. So the cache control header actually works on the request, and you can kind of say no cache on the request to, or max age 60 seconds to make sure you got information that's within the last 60 seconds or no older than 60 seconds. And so by understanding that the client is able to request fresh information if they want it, imagine like a hard refresh, they can do that. But then also being aware that there's amazing like combinations of strategies you can use where you set a longer, you can do as well as max age, S-max age, and that will set the expiry time on the CDN itself. And so you can kind of say, I'd like a longer cache on the CDN and a shorter cache on the client, and then the browser cache goes away and they're checking their CDN. And if it was super important that data was invalidated, you can actually invalidate the CDN. You can invalidate that yourself from the origin. And then things like ETags are the similar sort of idea, but we make it much easier, where it's just, if there's a massive response, instead of going, well, there's a cache rule of 60 seconds and there's 61 seconds ago since it was requested, so here's this massive 5 MB JSON payload, you could just have a much longer cache with ETags on saying, hey, has it changed since then? Has it changed since then? Has it changed since then? And if they're like, nah, man, it's all good, it's the same thing, you can go, oh, cool. And you get a no response. It's literally just goes, yes, that's fine, use that again. I think it's 301, who remembers? And basically, yeah, it's a much better way of saying you don't need to fetch this information over and over again. So it could be that the request doesn't go through at all, or it could be that it goes through and the response doesn't need to come back because you've already got a response. It's perfectly fine. And that mixed in with infinite other options, like only make this request if the original stuff is stale, or like only get this if something failed. Like there's loads of different strategies you can do to combine it all together. That means that most stuff should be cacheable, but we just don't do it because it's hard.
So I hope that most people don't took away from this that caching indeed is very complicated. It's not trivial, right? It's a little bit more nuanced than just setting kind of an expiration date. So there are many things you can do. You don't have to do all of them, but there are a variety of things that you can do. But also, and let's briefly talk about this, and that was the second article that you are writing. So the first one is about caching in general, how it works, kind of how HTTP defines it, and how it helps with HTTP APIs. And then the second one looks at a specific framework. So I think the main takeaway for that should be that if you decide to do caching, which we hope you will, then you don't have to implement all of that yourself, right? There's a lot of stuff there because it is part of the internet, so to speak, right? Or part of the web, let's say. So there's a lot of built-in stuff you can use. So once you know that it's there, then the implementation effort, so to speak, is actually relatively okay. If you could just briefly highlight that based on the example that you're giving there, mostly what I want you to do is encourage people to say, hey, it's simple. You can if your design supports it, right? Implementing it will be the least of your worries. You have to think about the design, and then implementing it actually is not the super hard exercise that you may think it is.
Yeah, for sure. I mean, I got into the weeds on some of the more advanced things that power users can do, and it's good to know that there are advanced options available. But if you want to get started, you literally just need to add like cache control header to your response, and you can just go right into your whatever framework, Node, Rails, Laravel, whatever you're using. You could just go in and right on the response put add header cache control max age 60, and it'll put a 60-second cache on there. Brilliant. that will immediately be picked up by browsers and anything that knows how that works. If you have a CDN in place with caching, then it will get picked up as well. If you aren't entirely sure, that you probably already have some sort of CDN in place. If you have Cloudflare, that's got a CDN in it. If you're hosted on AWS, you can enable CloudFront, which that one, and that is a CDN. And if not, you could stick something like Fastly in place. So talk to your infra team and see what's available. But yeah, the example I used for Laravel Vapor users is one specific hosting for one specific framework, but you can add one header. It's even got a middleware built in, actually, so you can just use the caching middleware to just say cache that for 60 seconds. And then I enabled CloudFront and changed the DNS to go through CloudFront, and then it worked, and it's fine. And it handles all the ETags, all the advanced stuff you could think of. So you can start with just that most basic thing, and then experiment with more advanced stuff as you find endpoints that are harder to cache. You just like practice with the more power features until you've got more of your API with cacheable stuff in it.
Yeah, that's guidance that I really like also, because that means that you can start kind of simple, right? And then when you see certain trends in your traffic and you see that, oh, most of my traffic actually is from hitting that endpoint, right? Then you can start thinking about, okay, is there something, can I improve the caching strategy for that endpoint, because there's something that I did. But you can only do that if your design actually started with some good modularization of your resources, right? So that's the thing that you can't get away from.
You can use that as part of the conversation and part of the loop. If you've got something like New Relic or Datadog and you can see like the most used endpoints, then you can start by putting some cache rules on there. And I've gone into companies that had the two most used endpoints were V1, get V1 users, get V2 users, get V3 users. So it's like, firstly, let's deprecate one or two of those bloody versions. But secondly, let's whack a few cache control headers on there. And we just put those in and we ran around a few clients, making sure they had the middleware to make the caching, respect the caching. And you just watched all these graphs just go through the floor. And then we're like, right, what's next? And you just start picking out endpoints and go a bit more caching on that. And if you do find some that are impossible to cache, use that to inform the design of the next API that you build, the next version of that API, or the next whatever API. Learn from those mistakes, and over time, more graphs be going down.
Okay, I like that. And my final question to you, since we now have found out that actually the important bit is to have a little bit smaller grained resources so that you can have these caching information for those, wouldn't it be the best thing to just use GraphQL for everything? Because then you can have kind of always the smallest, why are you laughing? You can always have the smallest possible resources by setting requests, right? Isn't that what GraphQL does for you?
Yeah, kind of. It mostly, it helps you make smaller requests easier, but it doesn't really do anything much about helping you with caching the whole way through the request response chain like HTTP does. There's nothing built into GraphQL that really outlines how to do caching. The documentation says you've got an ID number, go remember that response for a while, and it's put entirely onto the client to do. So it's a little bit different.
Yeah, that was basically just trolling you, so to speak.
I always serious answer jokes.
Oh yeah, you got pretty close. Phil, thanks so much for joining. I think that was a really interesting conversation. As you said, it's a topic that doesn't come up enough. It's a topic that has sometimes, I would say, some really low-hanging fruit in terms of improving the footprint of your APIs if you choose to have those APIs. So once again, I would like to encourage everybody to read those articles. I will, of course, link them from the description. Any final words from you from your boat, Phil?
From the boat, I really hope that you all do reduce the carbon footprint of your software, because the climate crisis has me stuck on a sandbank because it hasn't rained in 2 months. So the faster you cache your APIs, the faster I can get out of here.
Okay, I think there's a very direct call to action. So implement caching. Let's free Phil from his sandbank. Thanks everybody for watching. And if you like this, please give it a thumbs up. Subscribe to Phil's stuff. It's brilliant, all of it. And of course, also consider subscribing to Getting APIs to Work. That's it for today. Thanks a lot. See you next time. Bye, everybody.